For today's sharing session, we will be looking at a challenge by IDA, and the main goal of this sharing is to introduce the Z3 uh, SMT solver tool. And yeah, this challenge has something you can pick up to enhance your Z3 skill. So this is a table of contents for today's sharing session. So we will talk about Z3 in brief and challenge walkthrough and then Q&A. Yeah. So Z3 is a simple SMT solver by Microsoft. You can check it out at its GitHub over here. And yeah, it's basically solve those equations that contains constraints. So for example, we given a plus b equals to 1337, and there are many possibilities, right? And it could a and b could be the value of a and b could be. So maybe for case 1, a is 1337, b is 0. Then when they add together, it will be same as this 130. Or maybe case 2, 1336 plus 1 is also same. So there are many possibilities that could achieve the same result. So that's why this SMT solver is used to. Like we can give it constraint, a very complex constraint that it will need take quite some time for us to solve it manually using mathematical. So this tool is basically, this Z3 tool is basically will help us on solving it. Yeah, so we can see there are a lot of cases that could achieve the same result. So so the basic code, yeah, uh, for usual Z3 challenge in CTF, right? We only mostly touch the very surface of the Z3 function. So these are the example code. So we import a Z3 and then we create a Z3 solver, and then we declare some variables. It could be integer and etc. So there's or you can use the bit vector. So for your information, integer is 4 bytes, which is 32 bit. So these two are basically the same thing, but in some cases, when you perform some bitwise operation like shift left, shift right, rotate right, it's advisable to use bit vector instead, because yeah, it's bit it's involving bit, then use bit vector. And for this case, we just use integer, and then yeah, and then we just add our constraint. So this is what we want to achieve. So we add a plus b must equal to 1337, and later on we just check is that satisfiable. If not, we just yeah, maybe cry, and we can print out the model here. So for this case, Z3 show us the simplest result, which is b equals to 0, a equals to 137. Yeah, then we can get a result like this. Okay, so this is the basic code. So if you have any question, you can type in the message here. Yeah, I don't mind being interrupted too. So yeah, we will go straight into challenge walkthrough, because it's quite just a simple thing, but it's more when you're dealing with challenge involving Z3, right? Uh, it's more on logical thinking on how you convert those constraints into the code. So we straight to the challenge walkthrough. Yeah, we will demo solving hex array challenge, and you can follow it along, but yeah, it's okay. So this is the link. I can let me paste it here. I already copied the challenge to my VM, Windows VM, and I already opened it in IDEA. So yeah, okay. So as usual, log as man first. If you need the front to be more bigger, please let me know. I'm not sure if you all can see. How do I adjust this? Uh, okay. Is it okay now? All right. So before we should interact with the challenge first. So I over to my Kali here, and this. So this is the challenge. If we just execute it, it promise for the password. We just simply give it anything. So if we input the incorrect password, we'll get this picture. So that's all about this. So our goal, I think we need to provide the correct input. So switching back. So the main function is here. So yeah, you can see the error. You need to give the password for the argument. And yeah, if our argument is less than equal to 1, and this STL, we don't need to care about it for now because I think it's just standard rendering stuff. Let's quickly go through this before we dive deep into it. So all this STL function, right? If you Google it, it probably something about rendering, because just now we see a picture, and this level 4. Okay, we'll take note of it. So if you provide the password for our input, and then it basically go through something, and then from here you can see, right, it takes some part of our input. If it's not equal to 55449, it will go to level 4. So you can probably assume that you can debug it to verify it, but you can assume that this is the fail. Can I can say as fail, so to ease our analyzing. So first of all, you will copy this v3. V3 is our argument 1, which is our input to destination, and it's copying 24, and this destination only 16. So we can change it to 24 because that's the correct size for our input. And after we change it, just click yes. You can see the compilation is much more cleaner now, at least. And yeah, let me clean up a bit. Oh, I'm clicking the insert key on the keyboard. I just put some space here. Yeah, I think should be good. So right, actually we don't need this for now. So destination is our input. So input. Oh, I press the N key on your keyboard to rename it. And so the first thing is taking our input at index 16, 22, then perform some operation, right? And then eventually compare with 7380. If it's not, then we will straight go to fill, and then which literally just, I think it's rendering. If we click on this byte, right, you can see PNG, so we can assume that it's rendering the image we seen just now. So yeah, so our goal is fulfill all these constraints, and at the end it will show us a correct picture maybe. Okay, so so this is the first constraint, this is the second constraint, this is the third constraint, and this thing, it looks complex. We don't know it's constraint or not, but looking at it, it seems like it taking some value in the challenge itself, and then it minus based on our input. So what we given to the input, what we input will be minus, will be used to minus the bytes over here. And this bytes, we don't know what is it, right? So this whole thing, right, we need to further analyze to determine what it actually is. And if I highlight it, or maybe this one, okay, you can see if the field one is, okay, so this the field one is rendering the PNG, so this must be the correct picture. I mean, is reasonable, right? So the field tag is here, so this must be the correct picture. And this thing, right, we don't know what byte is it, and so we can assume that when our input is correct, and this byte will eventually being minus to our input, and then which will become a valid PNG, and then therefore render it in the end over here. So let's add some comment here. So we can rename this to maybe correct image. Okay. So moving on, this is another constraint. Because it's not certified, we'll straight go to fill. And this one is another thing that's similar to this. It's basically making sure that our input is correct, and then it will, for this case, is SOR to get the correct image. Yeah. So you can see it iterate byte by byte. If you maybe so maybe I should add a comment here. Okay, so moving on, this another constraint. If this is met, and then down here it looks like adding some our input again to this the collect image byte. And for now, I think we don't need to care about the function over here. So because eventually you just want the correct input, right? So we don't need to care about this, because if you click into it, it looks something complex to deal with. Yeah. So now we already map out all the constraints we have. We can start coding it. And yeah, I already have the source script over here. I will explain it in detail. Okay, first of all, same as the introduction just now, we create a variable. For this case, we use 24 because that's our input length over here. And for each of the input character, we give it a, a 8-bit value, because ASCII value is, I don't know, maybe it's at most 255, right? At most, I think only 122 at most for ASCII value. But it's okay, we give it 8-bit. So yeah, this is the standard thing. And this I will explain later. And this we add constraint. You can see we add for each character in our input, we add a constraint using this is a Z3 function, or basically saying that all of our input character must in the string dot printable. Yeah, that means all our input must be ASCII value. Why I like cut into the let me show you. Because the last 6 or 7 is actually not very important for us, so I cut it out. So remaining will be the ASCII value. Yeah. Okay. So we add constraint that all our input must be ASCII value, and all of the constraint down here is actually I literally just copy it from here. I will explain detail why I need to do this, and I think this is the tricky part of this challenge, maybe, because it requires us to convert it. Okay, and later on we just check if it's satisfiable. We just print out. Just yeah, that's it. So now we explain this part. If you look over this code in detail, right? Oops. You can see from the decompiler mode, but for more clear, you can see the disassembly, and it's actually okay. Let me so let's say our input. Is A B C D E F, and then in memory it will look like this. 1 2 3 4 5 6, right? And in hex it will look like this. Okay, so oops, So what this thing is doing, like, it actually not taking our input at index 16. It's taking the word WORD, which is 16 bits or 2 bytes. It's taking 2 bytes from our input at index 16. I will show you what it looks like for better. So let's say our input index 16 is 41. Let's say, for example, 41. And what this whole line does actually is taking 0s 41, 42, 41 and 42 instead of maybe like this. Yeah, so it's taking 2 bytes. So each of these are 2 byte, 2 byte, 2 byte. Yeah. And then it performs an operation, then compare with 73x0. I will show you what it looks like. So let me, this is 12A5 over here. Switching back to Kali. I just read on this offset, yeah. And then I ran it again. We need to provide 24 character, right? A B C D 654 24. I hope it's correct. Don't know what this is. I think this is the image, maybe. But let me close it. Okay, so you can see here, this is basically the same as this, the green part over here. Move something of word 2 bytes into EDX. Yeah, so it's single step. Oh, I think I need to run it again. I don't know why it's crashed out. Okay, with single step, and then you can see EDX is, yeah, basically what we just said just now. 4241. It's basically taking 2 bytes, not 1 byte. Yeah. And this seems like pretty clear for us, but when we convert it to Z3, like, it's actually quite tricky, because any minor mistake will lead to unsatisfied solution. So this is the lambda function. To 16 means to 2 byte, to 4 byte, to 8 byte. And okay, so it's using this concat. My God. So this is the concat. So actually, I already said, like, when you're dealing with bitwise operation, you're using bit vector, and then, yeah, this is where how it's come to useful, because this concat function, for example, this is the documentation, and it concatenating this bit vector value 1, and then 4 means this v variable will have value 1, which will total 4 bit. Okay, so this concat means 1 2 1, and and then when you show us, it will look like 289. Why 289? Because if you, okay, 4-bit, right? So 1 2 3 4, this is 1, this V is 1, and then 1 2 3, this is 2, this is 2, the V plus 1, and then another, which will result in 2F5. So this is what the concat function does. And yeah, I think the tricky part of this challenge is using this concat, because I'm not sure if you can do it without this concat, because it will be very troublesome. So now it's pretty clear now why we are doing this, because we separate, yeah, we can say that we separate our input to 2 byte per element. Okay, yeah, so you can see it concating starting from the highest value, yeah, higher address value than from lower. So same as this 32 and 64. Yeah, so any question for this? I'm not sure if you guys can understand. Yeah, so it's basically concatenating a byte to one part of this. Yeah, okay, then we create, because if you see, I'm creating 16, 32 and 64 because it's not only 16, because over down here you can see it will use 64 as well, and not this. Yeah, this is 32, and then also equals 64. Yeah, this is 64, this one. Okay, so I go through each constraint now. So the first constraint, this 7380, okay, why I'm um, dividing the index by 2, because we separate each of the input to 2 byte. We group them into 2 byte per element. So example, our input will be something like this. Yeah, yeah, something like this for x16. And then yeah, so we need to divide it by 2. I hope it makes sense for you. So 16 divided by 2, 22 divided by 2, 8 divided by 2, 14 divided by 2. Then we just compare it with, oh, is the loop at line 10 to 12 is um grouping all our input into different byte. A B C D E F H I J K. I think it's okay. So this is our input for example, and in memory it will be like something like what is K in hex? 4B. So 4B 4A 49 4A 47 46 45 44 43 42 41. It will be like this in memory, and this 216 especially change it to 4241. Yeah, basically this is grouping them in 2 bytes per group, and 232 will be something like this. Yeah, so yeah, something like this, and same as 264. That, yeah, so on. Yeah, something like this. Okay, so it's grouping them. Yeah, how many bytes per element in this array. And yeah, this explain it why we need to divide by 2 for F16 and divide by 8 for 64. Yeah, I hope it makes sense. So now we just converting all these constraint into this. Just type it in Python. Yeah. So 20, yeah, 6, 2, 2, 10, yeah. And then down here is this one. This one also same. 16, and then this is 0. Yeah, the first part of this input is 0. And then yeah, this just nothing. And then the next part is this. Yeah, I'll just copy it. For this case, DWOS, which is 32-bit. Where was it? Yeah, over here. 20, 0, 8. You can see times 4. And then 16, and then 4. Yeah. And the last one is this, the SOR. This input 8, 16. Wait. Oh yeah, this V7, if you track it back up here, you can see it was this 16. So that's it. We specify all our constraint now. If any of these not have some how to call it, like is any of this wrong, right? It will not satisfy, because Sec3 is very skeptical about this. Yeah, so we can just run it. So this will just check if satisfy, and then create a model for it, and then for each character you will take it and then convert it to character, and then append it to flag, and then we just print the flag. So we just run it, and we'll get this is the flag. You can try it out. Yeah, and then it will solve the challenge. Any question, because the next session will be the Q&A, I believe. Yeah, this is a soft script, and yeah, the Q&A, and then the reference I use. Yeah, so any question? Let me switch back. If you need. Am I too fast? I'm not sure. So our input will eventually just be calculate and then performs operation on the correct image byte, which will eventually, I believe, will be the ready picture. For now, you can see it's not like a ready PNG. We can try it out actually to see if our assumption is correct. Let's go to here. This one. I hope this is the correct one. 14E2. So we run it. It's not. Okay. I'm not sure if our the 55 at 9. Let's switch back and see this. Yeah, I can see this this correct image will eventually become the correct what the correct PNG header should have. At 954E47, which is correct at 954E47. Yeah, so it was correct image. Yeah, and then we just continue it. I believe, yeah, this is the correct image. Yeah, so if no question, I think we'll stop here. Yeah. Any more question? So if 9:45 no more question, where I can learn more about CTF? You can go to CTF time. Or you mean learn? I don't know if there is any proper platform to learn CTF. But if you want to play, you can go to CTF time. I basically learn through the write up. Yeah, you just keep playing, and then every time in the end of the competition there will be some write up, and then you just read it. Yeah, this all after CTF you can play for free. Um, yeah. Our Have you heard of SKR? If you say for Malaysia base, there is a SKR platform. It's by one of my senior. You can play as well. It's by Malaysian. gathered by Malaysia. Yeah. So, any more questions? What is the code? Oh, it's divide. I cannot. If you, yeah, just for safety, because let's say if you simply put one slash, it will have decimal value, which will result in error when you attempting to use it as index for an array. So we put two slash to get the non-decimal value. Yeah. All right. So I think we can end it here. Um, thank you all for coming. I will stop presenting. Okay, thank you. Uh, contact. You can contact me using my Discord. Maybe Twitter. Contact my Twitter. I think it's more suitable.